Hi everyone. Today we are going to talk about electronic configuration or electronic structure. Important part for AS chemistry or the A2 chemistry. But I will try to explain in a very layman terms. In terms of layman mean by I will go with the very easy way to remember how to write the configurations. As you know, the chemistry is full of exceptions. It have a lot of exceptions. So likewise, configurations also have exceptions. Let me think about how you have studied in your GCSEs. GCSEs we say, okay, we can say the first orbit will have maximum of two. The rest all orbit in the atoms will have 8 electrons. This is what we have learned in the GCSEs. The A level will be a little bit different. We will think about a concept called subshell. The subshells are we have subshells of S subshells, P subshell, D subshell, and F subshell. What is subshell is all about? It's all about electrons, where the electron is going to be live in. Think about for example, real life example. Think about a house. Yeah, house with a 1 bedroom house, two probably 3 bedroom house, or 5 bedroom house. Yeah, these are we call subshells. So S subshell we call, yeah, it have only one room. P subshell it have 3 rooms, and the D subshells have 5 rooms actually. So remember, S is 1, P have a 3 subshells, and D have a 5 rooms as it actually is. Okay, that's all about to understand. So as you know, as you learn in the GCSEs, I'm going back to this picture again. Over here, you have learned the first subshell, I mean first shell or first orbit near the nucleus. Because of it in the nearby nucleus, this shall have a lowest energy. So if I say first one have lowest energy, yeah, and it will increase by second, third, and fourth. It increase. It have incremental. So that means the first shell cannot have more than 2 electrons. That's the reason it was only we say 2 electrons. Okay. So the A level, if I just combine this together, the lowest energy shell only can have a 2 electron. That means that only can have S subshell. Yeah. The second one can have S and P. Yeah. The fourth one can have S, P, and D. Yeah. If I have a fifth one, in AS and A2, we don't have the fifth shell configuration, but I'm just telling you. You can have S, P, D, and F. I forgot about that. F subshell have 7 rooms. 1, 2, 3, 4, 5, 6, 7. So F, 7 rooms. Okay, does that make sense? Actually, I think it's really makes sense. So we'll think about how these S subshells, P subshells are going to be, laid out in later terminology. So we'll talk about S. As I mentioned, it's only 1 bedroom house. So only you can have 2 electrons. Therefore, I can put 2, S2. Again, all the S subshells can have maximum of 2 electrons. 2 electron is a not right terminology. It's about the two electrons in a different ways, but don't worry about AS and A2, please. Just think about S1 have only two electrons. Like the P subshell, it have three rooms in it. So one room can contain two electrons. Hence, it can have six electrons. Does that make sense? And the D subshell is a 5. Then it can have 10 electrons. And F could be 14 because there's 7 rooms. Right? Then the tricky part comes if the lowest energy, we call the first orbit. Yeah, we call just put 1 here. If it's happening second, we call 2. Just to identify which subshell we are talking about. Yeah, and the third, and the fourth. Yeah, it's the fourth. Sorry. Yeah, it makes sense. So if I try to write down the fifth one, 5s2, it could be a 5p6, it could be 5d10, and it could be a 5f14. Don't worry about it, it's a bit confusing, but I'll let me explain that one very easy terminologies. Okay, right. Now we have to remember an interesting part here. Always the electron try to fill in the lowest energy level first. Which is lowest? Of course, the first energy level is lowest, then second, then third, then fourth, then fifth. But the tricky part here is in between the subshells, there are some different energy levels are there. How going to look like? There's a principle called Afaf principle. You don't need to remember the principles here. I'm just telling about the principle by one of the Russian scientists that developed this principle very long time before. So this is the principle. He said if you draw the line like triangly, this is how the electrons get filled in. So the first electron is 1s2. The second one, we follow the lead over here, and this one. Yeah. Then the third, if we go over here, this one, this one, this one. Now if we follow the lead over here, now it comes to this one, 3d10, then 4p6, then 4s2. Yeah, that makes sense to you guys. Yeah, that's how the electron get filled in. Yeah, it's important to remember this whole thing. Yeah. So remember, first it fill. Let me change the color, then you'll understand. First, come on. First, it fill in 1s2. Second, it goes into the 2s2, 2p6, 3s2, 3p6. Before the 3p6, that goes to the 4s2, then 3d10. Okay, so that's how the electrons get filled in. Again, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d10. This is how electron get filled in. So remember this order always. Right. So now we have a problem or confusion why it is happening. So we'll think about why it is happening. So if I draw the line between the energy and the shells, yeah, so how it's going to look like, we'll think about that. So first, the lower energy is obviously the 1s. Then, if you look at this one energy, 2 and 2s and 2p. Again, if I look at correctly, 3s, 3p, and 3d. So now, if I look at the fourth shells lying between these two, because 4s comes here, then the 3d and 4p, 4d, and the 4f. So you can see what's happening here is, in terms of the energy level, the first, the 1s get filled in, 2s, 2p, 3s, 3p. Before we move into 3d, 4s get filled in, and we move into 3d. That's the reason I mentioned in previous picture. First, it's 1s2 filled in, then 2s2, 2p6, 3s2, 3p6, then 4s2, 3d10. But for the AS and A2, it doesn't matter. You can write it down like this as well. You can write down 3d10 and the 4s2. You can write it down like that. Acceptable. But remember, first the 4s get filled in before the 3d. That's the key point to remember. Yeah, I hope it makes sense. Actually, is. So we'll do a question here to understand how the configuration look like. Let's write the configuration of calcium. Calcium, as you know, it's a 20s atomic number. We do write the configuration for the atomic number. So we'll start with first one. So 1s2, 2 electrons, 2s2, 2p6. So we have 10 electron, 3s2, and 3p6. What will happen now? Before we put a 3d10, we put 4s2. Make sense to you? This is a really important part to remember, guys. So 4s2. So now if I count the electrons together, so all the superscript numbers being counted, so I have 20. So 20 electrons there, but this is the important part. Let me do another example, then you will understand further. We'll take potassium. Yeah, potassium is 19. 1s2, 2s2, 2p6, 3s2, 3p6, and 4s1. See, I haven't talked about 3d here. I just talked about 4s. Yeah, hope you understood that bit. Actually, is right. So that means now, let me do other example. Then we can have a pattern here. Let me take a chlorine. Chlorine is 17, which is 1s2, 2s2, 2p6, 3s2, 10, 12, 3p5. Yeah. So you can see the numbers. Let me change that, guys. It have a pattern here. Yeah, if you observe correctly, it's ending with 4. It's ending with 4. It's ending with 3. That means the number in front of the suborbits, which is the ending number, which gives you the period number. Which period they are belongs to, they are lying on. So chlorine is third period. And potassium and calciums are lying on fourth period. And the subshells, look at this one carefully, the subshells where they are lying on gives idea where these molecules could be found. If I draw very quickly the periodic table, it's look like this, isn't it? Yeah. So this bit, if I separate like that, this two columns we call S. Yeah, S molecules. This the bit in middle we call D molecules or D subshells or D molecules or transition metals. Over here we call P. Okay. So the ending part tells you it's a S molecule. It's a S molecule. Yeah, P, yes, P molecules. I'll come to the D bit later. And the over here, these numbers over here will tell you which group they are belongs to. As everyone knows about periods and group, right? So the period mean by these horizontal things we call periods. And the vertical downs we call groups. Yeah. That means this one say it's a second group element. You can see in a fourth period second group element. Over here this one you can see is a first group element, but it's a fourth period you can see. Over here is a fifth group element you can see in third period. That's the idea about this whole thing. Remember this bit, it's important for your exams. Usually they ask questions on this bit. Right. Interesting part. Well, think about if someone asks you to write configuration for K plus ion. As everyone knows, plus mean by it has been lost an electron. That's the reason it have the positive charge. It had 19 electrons. Yeah. Now it have only 18 electrons. Yeah. It was 19. Now it only have 18 electrons. So we write down that one. 1s2, 2s2, 2p6, 3s2, 3p6. That's the configuration for the K plus ion. Now K plus ion can be seen in P group or P block molecules, and it is in the third period, and the where I can see it's in the inert, because when you're counting the group number, you have to count the last orbit. Last orbit have 8 electrons, not just in 6 electrons. Last orbit, not the subshell. Likewise, we think about Cl minus. Yeah, it was 17 electron. Now it has been gained electron already, so it will be 18. So it look like this one again. Alright, it makes sense. Right. One more thing to talk about in D block electrons. So I am taking a molecule here. So we talk about a molecule now in the D block. So what does the molecule look like? So we'll take a molecule of vanadium. So vanadium, everyone knows the vanadium is 23 is atomic number. So if I write the configuration, it will be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d3. Yeah. Does that make sense? So now you can see the differences. The 4s get filled in first, then 3D get filled in. But the question now people ask, what is the outermost shell? Outermost shell is, there is no other opinion, other answers for that one. Outermost shell is 4s. Yeah. Suppose if I want to write down the configuration for vanadium 2 plus, vanadium has lost an electron. So as everyone knows, if electron wants to lose an electron, that's supposed to happen from the outermost shell. That's an important point. Please do remember that. Yeah. So you have a confusion. Everyone have a confusion. Which orbit they're supposed to remove the electron from? It's outermost shell. No other answers. No other second answers for that one. Which is 1s2, 2s2, 2p6, 3s2, 3p6. Remember 3d3. 4s, because it has lost electron from the outermost shell. This is the outermost shell. Hence, it has lost two electron from this one. This is the configuration for vanadium 2 plus. Right. Another important part before we conclude this video. Remember, the chemistries are full of exceptions here. So therefore, you remember two exception molecules here. Those are the chromium and the copper. Chromium is 24, copper is 29. These are quite often asked in your question papers, so please do pay attention. Write out now. 1s2, 2s2, 2p6, 3s2, 3p6, yeah, 4s2, and 3d, 4s2 and 3d4. This is how the configuration should, isn't it? But it shows some exceptions here, and it's ending with 4s1 and 3d5. I'll explain that bit why it is happening. Okay, so remember the configuration. You write down this whole bit, and you end with 4s1 and 3s2, 3d5. Sorry. But now you have confusion now. How are you supposed to remember this? Don't worry, only two molecules. So remember, two molecules easy, isn't it? So just remember that these two molecules only. Copper, 1s2, 2s2, 2p6, 3s2, 3p6, 3p6, 4s2, and 3d9. This is how it's supposed to be, isn't it? But because of the electrons have a different energy level, it have 4s1 and 3d10 as a configuration. This whole block comes up as end with this bit. Why it is important to remember why it's happening? Because the subshells gains a subshells gains the stable configuration. Yeah, the stable configurations in two states. One state we call half fill state. Second one, full fill states. What does that mean by? 3D5 is a half fill state. 3D10 is full fill state. Likewise, I would say P3 also half fill. Yeah, P6 is a full state. D5 and the D10. because this only exception happening in a D subshell. It never happens in a P subshells and a S subshells because of the energy levels, energies. D subshells are very far away from the nucleus of the atom, and it have a 5 energy levels. Hence, we say it can have some deviations. That means the 3D will borrow an electron from the 4s, and these both are getting more stable. Why? Because 3D5 is a stable state, and 4s1 also the stable state because a half fill of s, isn't it? Yeah. So they borrow the electrons and they get stable state. Why? Because the chromium and the coppers are metal. That's the reason. And this one is again, yes, to gain the full fill state, they borrow an electron from the 4s, and 3D gets more stable than the 4s because 4s is really far away from the nucleus, therefore some deviations are expected. That's the reason this whole thing happening. So remember, everyone, these are the two exceptions in the chemistry. So these have been widely asked in the paper. It could be a A2 paper or the AS paper. So please remember these two exceptions. And one more thing, do not memorize the stuff. Just understand how you write the configurations. And once you are fine with the configurations, yes, then you can try to remember stuff. But blindly memorizing, I'm not into that memorizing part. Right? Got it. So these are the important to remember the atoms and electronic configurations. One last part before we conclude. Remember this bit: S subshells, P subshells, D subshells, and F subshells. Right? How electrons are get filled in this specific one. Remember that electrons can be go upwards or downwards. We call clockwise or anti-clockwise. Hence, we mark electron in as a half arrow like this, and one other arrow goes down like this. So that's what I mean by S2. These represent two electrons. Yeah, and then P. First, always the one side get filled in. Remember this bit, yeah, is important. We call this a bus seat concept. If you get into the public bus, public transport, you always search a empty seat, isn't it? Yeah, obviously I do. So obviously everyone do that one. So we search empty seat or single occupant seat, and we just sat down there. So example, you are a passenger coming into the public transport. All the seats are get filled in. Then there you don't have any options. Then you will try to sit near to someone else. Yeah, electrons do the same thing here. So therefore, first they get filled single state, then they fill double. So remember this concept is very important part. So if you count this one, it have 6 electrons. D first always single. Yeah. Then you fill this one. Please to remember this. It's important for your exams. There's a questions have been asked to write or draw some things. Same thing. F. F never asked in the paper, but I just drawing this one for you for your knowledge basis. So F get filled in, and then it's get filled like this. This is 10, this is 14. Does it make sense? Yes. Right. So we'll think about a question we talk about using an arrow in box notation. Yeah, it's a name called arrow in box notation. Yeah. Give the electronic configuration of oxygen atom. Oxygen is 8. Yeah, 1s2, 2s2, 2p, 4. Yeah, it's a fourth group element you can find in a second period as a p block element. So what is that arrow box? Exactly what I draw here. Yeah, 2s2, again this one. Tricky part is p have 3 orbits. Remember, as I said about, it's a single seats get filled in first, then this one. I usually draw from the left to right, but follow the same thing. You can put this electron in any other orbits, doesn't matter, but always try to put from the left to right. That's the best practice. There's some reasons are there, but for the AS and A2, we don't need to know about that. But in a university, you will understand why it is important. Yeah, right. We'll think about another one, arrow and box notation for aluminium 3 plus. So first you got to remember what is aluminium's atomic number. Aluminium's atomic number is, let me see, aluminium, it's 13. Yes, 1, 3. So I could write a 1s2, 2s2, 2p6, 3s2, 3p1. This is a configuration of aluminium. Again, p block element and third group. Remember, third group in by last orbit, third group element, and you can find a third period. It might have a lost 3 electron because aluminium 3 plus, isn't it? So the configuration will be 2p6, 3s, sorry, 2p6. That's the configuration. Yeah. So what is the notation going to look like? Simple, which we know actually. 2. This one is very easy because it doesn't have a single electrons. What I'm drawing is because I know 2pc, that's why I'm just drawing like that. But let's practice single and fill up this one. So this how it's work. Yeah, perfect. I think I covered mostly about electronic structure on this video. I'll try to cover the next chapters in forthcoming. Also, I try to do some question and answers in a short videos things. But if you like this video, please give a thumbs up and do not forget to subscribe and press the bell icon. Then only you can see new new videos I'm posting out. And yes, thumbs ups and give your comments. And if you like to discuss about any other topics, please do give a comment. Then I can try to accommodate that. Thank you and have a good day.